Hello everyone, let's start today's class. Today we are going to learn the new concept, that is motion of an air bubble in a liquid. What is that? Motion of an air bubble in a liquid. So before going forward, let me tell you one important thing and some basic concept that you see here. If suppose you are having a container, I have drawn here, you can see. This is the open container and in which liquid is filled. You can see this, right? This is the liquid. And this liquid is filled till height h from the bottom. This is depth we can see. Now, see here at this point or those which are the points on the surface and the point which is at the bottom, there are two different pressures. Yes, at this point you will be having pressure, that is atmospheric pressure, and as you are going down the pressure will go on increasing, and let us assume that this is pressure B, PB. Okay, so this pressure how to find? I am writing one common formula. Pressure at bottom is equal to pressure at top plus H rho G. Okay, so here PV is what? Pressure at bottom. So therefore pressure at bottom is equal to P top means what? Atmospheric pressure plus H rho G. So this formula you keep it in mind throughout, and you always keep one more thing in mind, that pressure increases with depth. Understand? So have you seen some movies, particularly those who are doing diving, means for particularly inside water, they have one specially made suit when they are going below. Yes, means as they are going deep and deep in the sea, they are having specially designed suit, swimming suit, or but another diving suit we can say, that is. So that is made in such a way that whatever the pressure is going to increase when they are going down, that should not affect our arteries as well as veins. So there should not be no any external pressure on our body, so that our body functioning should be smooth. Understand? That's why they are wearing that diving suits when they are going down or deep inside the lake or sea. Got it? Why? Because pressure increases with depth. And for that you have this formula, that is pressure at bottom is equal to pressure at top plus H rho G. Okay, understood this? Good. Now, what is our topic? Motion of an air bubble in a liquid. Okay, so how it will be? First of all, you note down this somewhere at corner. This is just basic formula. So I want to erase this. So I am erasing this part. Okay, so here now what happens and how Boyle's law we are going to use for this concept. Let's see. So again, let me take one container. So I think in daily life you have seen fishes or fish kept in a glass box. Yes, and when means you might have observed that bubbles are coming up. When they are coming up, their size is going to rise. Yes, you might have seen this type of things in some shops or somewhere. It's like what you can say attractive things, right? So let's see here. So I have taken a container. Yes, this is a container, and this container consists of water. And now this is what a air bubble we can say. This is the air bubble. Its radius is what? Small r. When it is coming up, its size is becoming little big. And now let us assume that its radius is what? Capital R. Now here it is having volume V1. Here it is having volume V2. Yes. Similarly, let us assume that here it is having pressure P1, and when it is coming at the surface, it is having pressure P2. Understand? One more time, listen. I have taken a container and we are dealing or we are learning air bubble, how it is moving in a liquid. Then I have taken a bubble, air bubble, which is at the bottom of that vessel. And as it is going up and up, its size or volume is increasing. So when it is coming at the surface, its radius is r, and when it is at bottom, its radius is r, small r, isn't it? So volume at the bottom is P1, volume at the surface is P2. Similarly, pressure at top, that is at surface of water, is P2, and pressure at bottom is P1. Now, from Boyle's law, see here, from Boyle's law, क्या है Boyle's law? PV is equal to constant. Pressure into volume is equal to constant. Yes. Now, in this case, can I write like this? P1, P1 is equal to P2, P2. Okay. What I have written? P1, P1 is equal to P2, P2. Who's doubt? No. Now, we have the formula that is pressure at bottom is equal to pressure at top plus H rho G, and I am assuming that this height is how much here? Small h, up to which liquid is filled, or you can say from that height the bubble is rising. That is what small h. Now P at bottom is what here? P1 is equal to pressure at top means what you are having? P2 plus this is H rho G. Now P2 is what here? P2 is equal to P naught, isn't it? And this P naught value, you know, atmospheric pressure क्या होता है? H rho G, where H yesterday we have learned 76 centimeter of Hg. This is H rho G. Okay. So can I write like this? P1 is equal to P naught plus H rho G. So therefore P1 is equal to capital H rho G plus small h rho g, and then P1 is equal to capital H plus small h into rho g. What I did, I have taken common rho g. Rho g I have taken common. Got it? Any doubt? Now, here you see P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. So let's substitute these values now here in this equation. Understood? So next, we are having P1 V1 is equal to P2 V2. Now only we got P1 value. What is P1 value? H plus H rho g. So I am substituting at the place of P1 H plus H rho g into V1 is equal to this P2 value. What we got? P2 is P naught, that is atmospheric pressure. Yes, atmospheric pressure, and its value we know how much it is, capital H rho g into P2. Yes, if I will cancel this rho g and rho g from both sides, I am getting H plus H into V1, which is equal to capital H into V2. Yes, understood. Now, case number 1. Case 1, in terms of volumes. In terms of volumes or formula, I can say. Case 1 also not there. Don't want. So just note point you can say. So this is in terms of volume. As we know, P1 is equal to what? 4 by 3 pi small r cube, and P2 is equal to what? 4 by 3 pi capital R cube. This is what? Volume of that air bubble. So I am substituting these values in our equation. What I am getting? Capital H plus H into this P1 value 4 by 3 pi R1 cube is equal to capital H into V2 is what here? 4 by 3 pi R. This is what? Big R. This is what? Small r. So this 4 by 3 and this 4 by 3 will get cancelled, and I am getting formula H plus H into R1 cube is equal to capital H into R cube. This is also a formula in terms of radius. Okay. Next one. If suppose P1 is equal to n times, or V2 is equal to n times of V1, like that they have given. So here I am writing case if P1 or P2, we have to say, right? P2 is bigger, yes or no? P2 is equal to n times P1, then in this formula you can substitute H plus H P1 is equal to capital H into V2. So this is H plus H into this P1 as it is, H into n P1. This P1 and this P1 will get cancelled. You are getting H plus H is equal to n into capital H. Yes, means they are giving like that the volume of that point, that is that surface, is 3 times volume of at bottom. Then n is equal to what? 3 here, and then you can find out whatever you want, either H or capital H or whatever it is. So suppose now I have transferred this here, then H is equal to what? NH minus capital H, and then you are getting height H is equal to what? Capital H into n minus 1 for this case, isn't it? Like this formulas you can create by your own. Capital H is equal to what? N minus 1 into capital H or H into N minus 1. So this is what your first board. You can pause the video, note down the notes. And this is your second board. This also you can pause the video and note down. Okay, next. Now, if suppose case 2 I am taking case 2, if this capital R is equal to N times Ra. What is here? Capital R is equal to N times R. So now only we have learned this formula. You can see here. What is that? Capital H plus small h into R1. But here I have denoted only R. So you also mention here R only. No need of that R1. Okay. This is just R. No need of that R1. Next. So here it is what? R cube. So here it is R cube is equal to, this side is what? Capital H into R cube. Capital H into capital R cube. We know this formula. Now here capital H plus small h into R cube is equal to capital H into R is what here? N cube R cube, because R is equal to NR. Then this R cube and this R cube will get cancelled, and then you are getting H plus H divided by capital H is equal to N cube, and therefore N is equal to cube root of, if I will separate this, I am getting 1 plus H by capital H. This is cube root. Or if suppose I want something small h value also, you can find out from this. So if I want small h value, this is one formula. This is for n. And again, suppose I want taking cube on both sides. N cube is equal to 1 plus h by capital H. N cube minus 1 is equal to h by capital H. And therefore h is equal to capital H into n cube minus 1. This is also what the height is. Check it. It is very easy. Try to understand properly. Okay. So if you have doubt, you can ask me. You can call me. Whatever doubts you are having. Okay. So pause the video and note down this. And if you have doubt, ask. Okay. Next. Now solve this problem, which is very easy. Air bubble rises from bottom of the lake to certain height, rises from the bottom of the lake at certain height, at certain height its volume is 3 times that of bottom. Okay, at certain height its volume is 3 times that of bottom, then then find pressure and height at which bubble should rise. Okay, and height at which bubble should rise. Try to solve this, and you take atmospheric pressure capital H is equal to, or P naught is equal to 76 centimeter of H, or you take capital H is equal to what? 76 centimeter. Capital H is equal to how much? 76 centimeter. Got it? So try to solve this type of models. Okay, you try this and send me the solution. One more problem you have to solve. An air bubble rises from the bottom of a lake. An air bubble rises from bottom of lake, and its radius is doubled on reaching the surface, and its radius is doubled on reaching the surface. If the temperature is kept constant, and then depth of lake is, if temperature is constant, then depth of lake is. And here also you can take 1 atmospheric pressure is equal to 76 centimeter of H. Okay. Okay, this is the second problem. And one more you have to solve, problem number 3. If an air bubble rises from the bottom of a mercury tank, if an air bubble rises from mercury tank, rises from bottom of mercury tank, okay, rises from bottom of mercury tank to the top, its volume becomes 3 by 2 times than normal, means whatever it is at bottom. Then here also depth, find depth, and here also you have to take 1 atmosphere pressure is equal to 76 centimeter of H. Okay, so this is what the 3 problems I have given. This is second one, and this is number 1 problem. Air bubble rises from bottom of the lake at certain height. Its volume is 3 times that of bottom. Find pressure and height at which bubble should rise. And here also an air bubble rises from bottom of lake and its radius is doubled on reaching the surface. If temperature is constant, then depth of the lake is. And this one is third. Try this. It is very easy problems. Just try to understand. Use P1 V1 is equal to P2 V2 formula. Substitute the given things. Automatically you will get the answer. No need to hesitate. No need to take tension. It is very easy. Cool. Slowly. If you are not getting first time, what to do? Just try one more time. That's it. Okay. Just one more time you try and definitely you will get it. Okay. So solve these 3 problems one more time. Read the concept. If you have doubt, just call me. Don't send message because so many messages are coming. Direct call me and ask your query. Got it? So let's stop here and enjoy the day. Goodbye for today.